All right, welcome to the explainer. When we think about chess AI, we usually picture these super fast calculators, right? Just crunching numbers. But what if there's a totally different way to do it? What if an AI could play chess not by calculating faster, but by remembering?
So, what are we really talking about here? I mean, imagine an AI that isn't just some brute force machine, churning through millions of moves a second. Picture something else. Picture an AI that can tap into the collective wisdom of, well, every great chess game ever played. It could learn from all the successes, all the failures of every grandmaster throughout history.
And hey, this isn't just some sci-fi fantasy. It's a real concept, and it's built on a pretty cool piece of tech called a temporal graph database. And the goal here? It's to create a chess AI that has a perfect, encyclopedic memory of the game's entire history. Pretty wild, right?
Okay, so how does this whole thinking process actually work? I mean, how is it really different from the big engines we all know, like Stockfish? Well, it all comes down to the underlying structure.
So a normal engine, right, it creates this temporary search tree for one turn, and then it just throws it away. Gone. This approach, it's completely different. It builds one single massive permanent web of all known chess knowledge. Just think of it like this. Every unique position on the board is a destination, that's a node, and every move is like a road or an edge that connects them. It's basically a living, breathing map of the game's entire history. And this really shows you the fundamental difference, doesn't it? You've got the calculator on one side. It's incredibly fast, for sure, but it's also forgetful. It literally starts from scratch every single turn. But then you have the historian. It never, ever forgets. It's not just calculating, it's recalling. It understands the context of a move because it knows everything that's ever happened in the game before. And this knowledge graph, it stores so much more than just the moves themselves. For every single position, it knows how many times it's been reached in history. It knows the stats, the wins, the losses, the draws, from that exact spot on the board. It even handles something called transpositions, which is really just a fancy way of saying it knows when different move orders end up on the exact same board. All of this together creates this incredibly rich context that a simple calculator, well, it would just miss it completely. So what does all this add up to? Well, you could say it's an almost unfair advantage. I mean, tapping into the memory of millions of past games gives this kind of AI a totally different way to look at the board. This is where the AI can really move beyond just pure calculation and get into the realm of strategic wisdom. It can actually recognize patterns and plans that have worked for human grandmasters for over 100 years. It's kind of like having every great chess mind in history whispering advice right in its ear.
So, how does that actually play out in a game? Well, the AI might get to a certain position and see from its database that one specific move has led to a win, let's say 55% of the time, over thousands of historical games. So it's not just asking, what's the best move according to my algorithm? No, it's asking, what move has the best proven track record of success out there in the real world? And here's the really crucial point, explainability. A modern neural network, it might play some brilliant genius-level move, but it can't tell you why. It's a complete black box. This historian AI, though, it could actually justify its decision by citing its sources. It could literally say, hey, Capablanca played this move back in 1922 and won, so it looks pretty good. That makes its logic totally transparent and easy to understand. Okay, but wait a minute. If this idea is so powerful, why don't we have it, right? Why aren't all chess engines built like this? Well, the answer, it's a challenge of almost unimaginable scale. So the number of possible unique positions on a chessboard is it's astronomical. We're talking about a 1 followed by 43 zeros. Trying to build a database to store every single one of those, it isn't just hard, it's completely, utterly impossible with any technology we can even dream of today.
And no, that's not an exaggeration. A complete graph of every possible chess position isn't just a big data problem. It's a planetary scale data problem. The amount of storage and memory you'd need it's beyond our reach, period. And look, even if you could somehow store all that data, there are other huge hurdles. For one, trying to search a database that big would be way too slow for a tournament game. And maybe the biggest problem of all, the AI would be totally blind to anything new. If an opponent plays some creative move that's not in its history books, the historian AI would just be stumped.
But this doesn't mean the whole idea is a failure. Not at all.
In fact, it points us toward a much smarter, much more practical future for chess AI. A hybrid future that, believe it or not, is already taking shape. See, the top engines today, they already do this. They use the best tool for each phase of the game. So in the opening, they use a graph database, we call it an opening book, for all the well-known theory. Then, for the super complex and new positions in the middle game, they switch over to a powerful calculator or a neural net. And then, at the very end, when there are just a few pieces left, they query another database, an endgame table base, that gives them a perfectly solved, guaranteed outcome. So really, you end up with these three different minds, these different philosophies of AI. You've got the raw power of the calculator, right? Then there's the human-like gut feeling of the intuitive prodigy, and finally, the deep knowledge of the encyclopedic historian. And as you can see, each one has these incredible strengths, but they also have some pretty critical weaknesses that could be exploited. And honestly, this is the key takeaway. The ultimate chess AI probably isn't about picking just one of these minds over the others. No, it's about a powerful synthesis of all three, combining the calculator's raw speed, the prodigy's intuition, and the historian's deep wisdom. That's how you create something that's way more than the sum of its parts. And that really leaves us with a final thought, doesn't it? As we keep designing smarter and smarter AI systems, this fundamental choice between pure calculation, gut intuition, and deep historical knowledge, that's a question we're going to have to answer over and over again. And it's a question that goes way beyond the 64 squares of the chessboard.